going on? Hi. Okay. So I'm going to talk about Bluecat today. Who's heard of Bluecat?
Heard of it.
Before today?
Yeah.
Awesome. Okay. So this is a project inspired by Netcat. So everyone knows Netcat, right? So hopefully this will be an equivalent in reputation someday to what Netcat is. Right? So let's talk about what we're going to be talking about. Okay. So what's significant with Netcat, right? What is it? What are we really talking about? All right, we're talking about sockets, right? But not these sockets, right? We're talking about sockets. Wait, no, not those sockets. These sockets. No. No. So I was looking for pictures of sockets, and I found this one, and it's a lot like interposition, right? Like that's. Do you guys remember these? I recently found out that in the old days you actually like plug your devices into your light sockets to start before we had wall jacks. So this is an early innovation. Okay, so one thing that people do on the internet, right, is look at pictures of cats, right? So what can this really be reduced to, right? When you play a cat video, right? We're talking about streams. So every like data source is going to be reduced to some stream, right? Theoretically, this is true, right? You can turn everything that ever exists on computers into a stream of zeros and ones, right? In some fashion, right? And they're awesome. That's like an amazing abstraction, right? Both like in practice and theoretically. So to achieve this cat business, right? We'll take some video stream, and we'll take some video file and we'll stream it to some application, right? That's gonna run. So I mean, some applications access files differently, but for the most part, let's just think about things where you can turn stuff into streams, like videos, and run them with some video play, right? So when you're doing it locally, it's just a straight shot, right? I mean, there's a lot of stuff in between, but it's pretty much, there's not a lot of complication. When you do it over the internet, it adds a little bit of abstraction, but this is kind of solved with Netcat, right? You can just take the socket, which encapsulates the stream, and just shove it over a Netcat socket. So with this tool Bluecat, we can do the same thing really easily with Bluetooth, using Bluecat. So each side is using Bluecat, and you can kind of bridge the Bluetooth divide while doing something like a script, right? So I mean, you can do all this stuff programmatically, but coding with Bluetooth is a real pain. Like, who's written a Bluetooth application? Nobody, okay. So now you can just write a script and achieve this wireless coolness, whatever, this wireless, you want to manage something wirelessly, it's easy. You don't have to like learn a Bluetooth stack and then make sure everything works and debug all this stuff. So one big piece in this is how the stack, how this program's kind of laid out, which I'll go over in a minute, but it's really designed to work on everything, so you can kind of use it. So I've gotten this to run on a Raspberry Pi, and then a Chromebook with Ubuntu, and then a Mac. I haven't tried Windows, it probably works on Windows. All the software that I'm using supports Windows, but I haven't tried. So it should run on like pretty much every platform that people think of, like Symbian cell phones even support this stuff. But you never really have a command line access to it. But this library that I'm using underneath to code this whole thing supports like everything. All right, so we can typically kind of use a stream with this kind of method in a script, right? So you cat some file, that's going to give you some stream, right? And you can just direct that stream anywhere, right? If you cat a big movie, it's going to look horrendous on the console, right? But you can pipe it some other place, like to a file, right? Or directly to VLC, right? Let's say we don't have this internet divide here, right? You can just cat this thing into VLC, telling it to read from standard in, and just play the video. So we can kind of bridge the gap over the internet one way, and then we also want to have a equivalent method with Bluetooth, right? So how does this look like in Netcat, right? So we cat something. So think of this as like between these spots, right? So we netcat to some machine name on some port, and then the thing that we're going to was listening on some port and stream exits, right? Okay, so screenshots out of order. So with Bluecat, we specify some URL and then a monk here, or whatever you just call it URI or whatever. Anything. So it's a protocol, MAC address, and channel, right? And that's gonna go to Bluecat listening on some of this stuff. So this kind of mimics the way you'd use Netcat for these things, right? Some problems with like available channels, like if someone's hogging a channel, you can't, like, by default it will, like when you start listening, you say I want to listen on channel 4, it'll just listen on channel 5 if 4 is already in use, and it just does this automatically. But there are ways to deal with that. So it's kind of this similar scheme, similar use cases to Netcat, so the learning curve is just identical to what we've already know. All right, so let's go to println. So if you run it, you get a nice text cat, and then it's going to list all the things that you can do. So let me go over these things. One other kind of component that Netcat is missing, right, and Nmap fills that gap, right, is just to look at what ports are open on something, right? So you guys have all seen this output. Nmap running, and we have a port number, protocol, and it's open, and there's some identifier to say what it is, right? So there are 2 ports open on this thing. Now, for Bluecat, that's kind of like a 2-tier system of discovery. Because it's easy to just connect to things, but it's way more useful if you know what can be connected to. So that's why this stuff's built in. So the first step is just scanning for devices around you. So here we have 3 devices that this thing found. All right, it did that using like the service discovery protocol for Bluetooth. But the command line for this, you just did Bluecat devices, and it's going to search around you for all the devices that are in your proximity, right? So it's the same stuff that you'll see in the Bluetooth connection managers, depending on how open your laptop is, right? So this will display anything that's listed as visible, right? So it's going to show you a timestamp, right? This is actually some old output. So now it shows a timestamp and then the MAC and the name. Then we have whether we're connected and whether the connection's encrypted, right? So trusted is going to be if you're paired, right? One big stem from this whole, one big angle of this talk is there's no real big problem with Bluetooth. It's really just how you can use it better. Unless you're paired with something, you really don't have a security problem. That's not what this talk's about. But once you're paired, then the kind of chains are taken off, and it's the Wild West between 2 devices which you pair. So if you pair with your headphones, maybe you'll understand what I mean in detail in a second. When you pair with your headphones can read your contact list, so that's not really a good thing. Unless your operating system unless like Android or one of these things prevents you from reading that contact list. But it usually asks you again. It says this Bluetooth device is trying to contact this. It's trying to read your contact list. You want to allow this, right? So it's gotten pretty secure. I haven't found any flaws on that level. But anyway, okay. So we can see 3 devices here, right? We see their names, as you'd see them in the managers, right? Right, we can go on farther to now look at the services as well as the devices, right? So here we want to look at the 3 devices that we were just looking at. We can just easily do this with Bluecat services, right? It's going to say all the services available around me, right? Same thing with devices. So for each element, it's going to say searching for services on this Nexus 7. We have a timestamp, device name, the service name. So it's going to give you a description. So like which one looks like someone's playing around, right? You can see like hello world. Someone's probably writing a test application. There's probably some flaws in how they implemented that, right? So if you scan iPhones, it's funny, you can see that they have like random apps. I've scared a lot of iPhone users because they don't think that like they're broadcasting a Bluetooth access point, but some of these apps do that, so it's kind of fun. But you still need a pair, so it's not really a security issue. And then you get the protocol string listed at the end, right? So this is what you'll use to connect, so I'll show that in a second. But we have a similar format. I have a whole slide for that. Okay. And then we see that similarly for each device. So you can actually see what they're broadcasting that they have listed, right? All right. So for stuff that you want to discover even more, if it's not like broadcasted by the device itself, you can just try a connection and try, like, in effect scan it, right? So we can try to make a connection on the first 30 channels that are available in Bluetooth for a specific MAC. So even if it's not visible, if you have the MAC, you can scan it, right? So if it's trying to hide itself, if you use something like Ubertooth, right? You can discover the MAC addresses of these Bluetooth devices flying through the network, right? You can grab one of those MACs and then scan it with this, try all the RF COM ports, right? And these aren't just RF COM ports, these are the channels in general. Some of them are RF COM ports, so this is going to be, these are 3 RF COM ports in a row, and then you have, I don't know if I have listed here, some of them show up and they'll say, oh, it's a OBEX port, right, which this doesn't handle yet. But you get to kind of probe the machine on this level without it actually thinking that it's visible to anybody. Okay. And that's just done by Bluecat scan and then some MAC. Okay. All right. So the Bluetooth URI monkey, right? So this is this thing that kind of gets used to connect to Bluetooth devices, and whenever you're kind of talking about a service, you'll be dealing with one of these. All right. So the only one that Bluecat supports is this Bluetooth serial port protocol, also called RFCOM, right? There are some other ones. There's L2CAT. I don't know how you even use that in a command line utility. And then there's Object Exchange, so I don't know how you use that either. So the one we really care about to emulate Netcat is this Bluetooth serial port protocol. And this takes care of all the sequencing and rate control and all the stuff that has to go on with the connection between point A and point B. But that's easily said in this monkey restrict, where you have this connection protocol here, and then next to it we have the MAC address, right? So this is not a real MAC address, because all the MAC addresses you'll see here have been changed a little bit, so they're not exactly the devices that I know. So you don't have IP addresses because you don't need this like network layer. It's all about proximity, like who's around you. But they follow the same convention as regular MAC addresses, so you can look up the hardware manufacturer just as you would with an Ethernet MAC address. So, I have a slide for that? No, I have one in a second. So, the first 6 will give you a manufacturer, right?
Isn't it true that they're unique also in the address space?
No. So they should theoretically be, but these cheap Bluetooth devices will have the same MAC. Like this, the manufacturers, the resellers like say this when you order from like some website. They're like, well, these will probably all have the same MAC. No guarantee, right? So you shouldn't buy a bunch expecting them to each communicate, right? But if you buy one little USB dongle from Amazon and then you use your phone and your laptop, they'll most likely be separate, right? But if you buy the same devices, the manufacturer could use the same MAC. So they don't have to be unique. And if they're the same, then you won't have it. Right. So, cool. And then at the end you have a channel number, right? So there's a bunch of kind of well-known channels that I didn't document. They're just kind of repetitive. I'm still kind of scanning and building a database of all these things. Which is, you'll see the output of Bluecat looks like it's a CSV file that's meant to be imported into a database. It's because it's designed that way. So if you think about the other angle of this is, and it also runs on a Raspberry Pi. So all these things, you can kind of stitch them together to throw a Raspberry Pi somewhere with a Bluetooth dongle, plug it into a wall outlet, and scan for months. And then you can kind of monitor people with Bluetooth devices all around. So that's the only really problem with Bluetooth, is that everyone can see. I think someone mentioned that earlier today with cars that have Bluetooth tire sensors, right? It's the same thing, but we're walking around with these beacons all the time, right? Okay, so let's look at some devices. So let's say we scan. This was the first thing that I actually found that worked like unexpectedly. Like I discovered something interesting. It was with this printer that's down the hall from my office. So I scanned, and I got this result. We got a timestamp, a MAC, and a name, and then some other information about the device. But first, we can go look up the first part of this MAC, and we find that it's microlink communications. So it's not where the Ethernet might say HP on this printer. there seems to be no correlation between the Bluetooth dongle or the Bluetooth chip that they used and the manufacturer, right? So you can't really tie it together. Like if you scan a bunch of devices, you can say, oh, those are all Apple devices, right? It's kind of useful, actionable information. You really can't draw any correlations unless microlink is only used by HP chips. So I haven't seen any correlations like that. So that's not very useful. All right, so let's scan this. Let's look at the services on this thing. Right? So we Bluecatify this printer, right? Or we throw Bluecat at it. Okay. So we get some results back. The name again, and then we have 4 services going on. And then you can see the protocol. So one of them is we can actually work with, right? It's the Bluetooth serial port protocol. It actually says serial port, right? So what happens when we connect to it? So the way you'd connect to it, right, to the serial port, because it's a BT SPP, is we do Bluecat and then -URL, right? And then you pass in whatever's at the side of your scan results, right? And you can just do this with each service. And you can just see what happens, which is usually what I do these days. Now when you do this, like most phones, they're going to get pairing requests. Okay, most things they will refuse to establish an insecure connection, right? Which is by design. It's a good feature. But a lot of devices also don't, like this printer. So you don't need to pair with this printer. So it makes it a lot more fun. So if we do Bluecat-V for verbose, right? And then we pass the URL that we just had, right? And then it's going to spit back. Verbose is going to tell us when we're connected, right? And then it type something like, "Dear sir, your serial port is showing." And we use Bluecat to talk to this printer, right? It'll actually print out the plain text that we type in this thing. So who's done port 9100 on a LaserJet printer or like some JetTrack thing before? 9100? Okay, a few hands. So that's inspired me to start playing around with this. And I ended up printing a lot of paper on this guy's printer. So the next thing I tried, so the 9100 thing is these HP JetTrack printers will accept PostScript and PCL. Where you can like convert a PDF to PS, and it'll generate a PostScript file. And then you can just cat that to port 9100, and it'll print it. So I was like, well, it's an HP printer, it should work, right? So I printed a PostScript file to this printer, and it did not print it did not print what I thought it was going to print. It printed what I sent it in text. So it happened to be a professor's printer, and he was like, "Who is printing on my printer?" Like walked down the hall. He's like, "I can tell. I know. I can tell who's printing to my printer," and he came right to my door. He was like, and I was like, "You don't understand. I just made this really cool thing." So yeah, it was funny. So it ended up printing on stationery. It was funny. Pretty good. Okay, so now, so that was fun. That was we explored something and kind of wrote a driver, and he had no idea. He was like, "Yes, you installed the thing from HP to do that." And I was like, "No, I just sent characters to the socket that was listening." Right? Okay, so look at the next target. Okay, so when I first made this thing, every person that I came in contact with was like, "Let me scan your phone. Turn your Bluetooth on. I want to see what's going on with your phone." And most phones are secure. Like iPhones, you can find some cool stuff with like they have like iApp wireless access point or something. That's the funnest. It freaks everyone out because they think they're sharing all their information, right? But really nothing interesting on those. But this was an old phone. I found it an old phone, so I scanned it, and this is the model of this phone. So I scanned it, we Bluetoothed it, right? We Bluecatted it, right? I need a catchphrase, so if you think of a good catchphrase during this talk, like we have Netcat is a Swiss Army knife of whatever. The network Swiss Army knife, right? And then Ncat as Nmap as a terrible name. It's like free network scanning device. But if you think of one for Bluecat, let me know. So I think Bluecatified, maybe? Okay. So we search for services on this Mac, right? And it's a Alcatel, whatever, One Touch. So we get some services back. We have 3 or 4 Bluetooth SPPs. So I kept connecting to a bunch of them. And then I connected to this serial port, I believe it was. Yeah, so channel 11. Channel 11, right? So we mentioned it. that's really the only thing that's varying between all these sticks. So these are all repetitive. So when you save these all to a gigantic set of files, like I have, you can just grep for certain things, and you can do statistics, which I don't have any graph today. So I apologize for that, but it would make it for another talk. So we connect, Bluecat, URL, channel 11, and then I was like, I seem to be able to connect, and it does stuff, right, when I connect. It gives me like error messages and stuff. So I was like, there's something more going on with this phone than all the other devices I saw. So I started just typing random things. I think I I did AT once and I got a weird error, and I was like, okay, there's something going on with AT. So I started looking up, who's ever heard of the AT commands? Yeah, okay, so tell other people about it, because they still use it everywhere, right? So this is like before my time, not to make you guys feel old. So I started looking, and like, I was so excited, I think I have a page of links with AT commands on it. But it was kind of hard to find all the AT commands. I kept Googling, and like, there was no right thing to say, like, mess around with someone's phone using AT commands. Like, I didn't know what to Google. So, yeah, so you start doing this and you get results back. So I did AT plus CGMI, right? And I got this CGMI, and I got the manufacturer, right? was the model, right? And then I get the whole string with some other stuff. Yeah, you can see the date on that thing. How's that one?